Hello, this video is going to take a look at locus. So what is a locus? Oh silly, that's a locust. We're going to be taking notes on these pages in your packet, and to start with, let's define a locus. A locus is just a set of points that satisfies a certain condition. The example given here is that headlights and taillights form a locus as they travel along the road. In Latin, the word locus means place, and the plural of locus is loci. There are 5 basic locus theorems. The first locus theorem asks what is the set of points that are at a fixed distance d from point P? And that would be a circle. P is the center of the circle and D is the radius. The second locus theorem defines the locus of points a fixed distance d from one given line, and that would be a pair of parallel lines that are each d distance away from L on either side. Notice that we draw locus with a dashed or dotted line to represent each of those points satisfying the condition. The third locus theorem is the locus of points equidistant from 2 given points. And we know this from the perpendicular bisector of a segment theorem, that any point on that line is going to be equidistant from the endpoints of the segment. The locus of points equidistant from the endpoints of the segment would be the perpendicular bisector. The fourth locus theorem. The locus of points equidistant from 2 given parallel lines would be a line parallel to both the given lines and midway between them. And the last major locus theorem is the locus of points equidistant from 2 intersecting lines, L1 and L2, is a pair of bisectors that bisect the angles formed by L1 and L2. And not coincidentally, they will also be perpendicular to one another. We also have 2 not-so-main locus theorems that deal with circles. And the first one is the locus of points a given distance d from a given circle is 2 concentric circles that are each d away from that given circle. If you think about this picture, this distance is d and this distance is also d. And the last locus theorem, number 7, the locus of points equidistant from 2 concentric circles would be a circle that is midway between both of those given circles. If we think about problems, basically you're expected to either identify the number of points satisfying the condition, describe the condition, or draw a picture. Looking at the example down below, it asks you to sketch and describe the following. What is the locus of points equidistant from 2 parallel lines that are 12 centimeters apart? The first thing I would do is draw those parallel lines. After I draw the parallel lines, I would sketch my locus. And then I would show any detail that's necessary. If the 2 parallel lines are 12 centimeters apart, then this would be 6 centimeters. Okay, so that's basically the idea behind sketching a locus of points. Then we also have to solve problems that relate to compound locus. Compound locus is just more than one locus in a given situation in the same sketch. So we draw the locus of points that satisfy the first condition, draw the locus of points satisfying the second condition, locate the points of intersection, mark with an X, and your answer is either the number of points or the sketch, again, depending on what the question asks. Let's take a look. The first example tells you that AB and CD intersect at E. So I want to draw AB and CD intersecting at point E. Now I also need how many points are equidistant from the intersecting lines. So I have to draw my locus of points that are the angle bisectors there. They're equidistant from those lines. And then I also want 3 units from point E. So we know that that's a circle around point E, 3 units, and so this is 3 units away, and my locus of points that satisfy both conditions, there are 4 of them. I usually just mark with an X and circle it to make it a little bit more identifiable, and they just ask how many points, and then we answer the question 4 points. And that's basically compound locus. Sometimes you'll be asked to do this on a grid or even a coordinate graph. Let's take a look at one of these. Points L and P are 8 units apart, so I sketch L and P. How many points are equidistant from L and P? Well, I know that that has to be the perpendicular bisector of segment LP. And then also 6 units away from L. So 6 units away from L is going to be a circle with a radius of 6. I kind of go off my grid there a little bit. That's okay. It's not going to affect my answer because I really don't need to continue that sketch beyond here where I find my 2 points of intersection. So 2 points. And these questions do expect, even though they're just asking for the number of points, they would expect that the sketch goes with it. Okay, so that's locus in a nutshell. And you'll have plenty of practice with locus and compound locus in your packet. Have a great day.